Hi everyone, I'm here to help you with number 4. A duck farmer wishes to build a rectangular enclosure of area 100 meters squared. The farmer must purchase wire netting for 3 of the sides, as the fourth side is an existing fence. Naturally, the farmer wishes to minimize the length and therefore cost of the fencing required to complete the job. If the sides adjacent to the existing fence have the length x meters, show that the required length of wire netting to be purchased is L equals 2x plus 100 over x. Okay, so they told me to put the adjacent sides as x, so I'll call the other side y. And they also told us that the area is 100 meters squared. So area in this case would be x times y is 100. And I'm just going to go ahead and isolate y because I'm going to have a system of equations. So I'm going to isolate y to be able to use substitution. So I'm going to divide both sides by x, so y equals 100 over x. So now if we think about the length of wire that she needs to use, she needs to add up all 3 sides. So x plus y plus x. So that's 2x plus y, and we just found out that y is 100 over x. So 2x plus 100 over x. Okay, so that's part A. Now, part B wants us to find the minimum value of L and the corresponding value of X when this occurs. So I need to minimize the length. First, I'm going to start out by rewriting it as 2x plus 100 times x to the negative 1. So now I'm going to take the derivative, which would be 2 minus 100x to the power of negative 2. So the derivative is 2 minus 100 over x squared. I'm going to set that equal to 0, and then I'm going to subtract the 2 over, and then I'm going to multiply both sides by negative x squared. So I would have 100 equals 2x squared. I multiplied by the negative, and the negatives canceled, and I multiplied by the x squared. And then divide by 2, x squared equals 50, so x would equal plus or minus root 50, but since this is the side length, it should only be positive root 50. And I'm going to go ahead and put root 50 in my calculator, and I get 7.07. So that's one side length x. The other side length y, remember y is 100 over x. So 100 divided by that, the other side length would be 14.14. And they wanted us to find L. So remember, L is 2x plus 100 over x. So I'm going to say 2 root 50 plus 100 over root 50. I'm going to plug that into my calculator. 100 divided by root 50, and I get the length is 28.28. But we did not check that this is a minimum. So I'm going to check that this is a minimum by making a sign diagram. I'm going to plug in 7, and I'm going to plug in 8 to the derivative. So 2 minus 100 over x squared. So 2 minus 100 divided by 49 would be negative, and 2 minus 100 divided by 64 would be a positive number. So this is decreasing the increasing. That is our minimum. So let's make sure we answer the question. Find the minimum value of L and the corresponding value of X for when this occurs. The minimum length is 28.28 meters when x is 7.07 meters. Okay, and then C wants us to sketch the situation. So we have 7.07, 14.14, 7.07 meters. Okay, I hope that helps. Have a wonderful day.